Hi, in this video we'll do an example for the test for the concavity of a given function. Question asks for the intervals on which function 1 over x squared plus 3 is concave up or down. Okay, remember that the test says that you have to find the sign table for f double prime. Wherever f double prime is positive, f is going to be concave up. Wherever f double prime is negative, then the function f is going to be concave down. So let me start with the first step. Step 1, we are going to do find f double prime. Okay, so f prime is f of x is 1 over x squared plus 3. Then f prime of x, you either use the quotient rule or use the power plus chain rule. You get negative 2x over x squared plus 3 squared. Then to find f double prime, we need quotient rule. It will be derivative of numerator negative 2 times the denominator minus the numerator, which is negative 2x, times the derivative of the denominator. Remember, x squared plus 3 squared, the derivative is 2 times 2x times 2 times plus x squared plus 3 to the power 2 minus 1. So it means that I have 4x, make it black here. And this is 4x times x squared plus 3. And then the denominator before was x squared plus 3 squared. Now square that one itself. Well, let me simplify here. Something that we have to note here, since we are going to find the sign table for this, it's better to simplify at this stage. You see that x squared plus 3, we have in both summands we have x squared plus 3, so we can factor out x squared plus 3, and in the first one I get minus 2 times x squared plus 3. In the second one we get just 8x squared. That's it. And then x squared plus 3 to the power exponent of exponent, you multiply. Yes. Now you can cancel this with that. You get 3 in the denominator. So here is negative 2x squared plus 8x squared is 6x squared minus 6 over x squared plus 3. Okay, now that's step 1. Step 2 is find the sign table. Find the sign table for f double prime. Okay, to start with, I have to set f double prime of x equal to 0. It means that I have 6x squared minus 6 over x squared plus 3 squared equals to 0. A fraction is equal to 0 if and only if the numerator is equal to 0. And from there we have 6x minus 1, x plus 1 equals to 0, and that gives me two roots. X either is equal to 1 or x is equal to negative 1. Okay, when we have those ones, we do start working on the tables. First, put the roots in the right order. So negative 1 here, plus infinity. And the function is defined every x squared. The denominator never is 0. So then this is also 0 here, 0 there. I need the test values. Here I need to put 3 values here and here. So here I will get 0 to negative 2. Okay. Then I have to evaluate the f double prime in every single test value. So f of -2, f double prime at -2. So it is 6 times -2 squared minus 6 over -2 squared plus 3 cube. Yeah? And you see that the numerator is 4 times 6 minus 6, this is 18. The denominator is 4 plus 3, 7, 7 to the power 3. Numerator is positive, denominator doesn't matter what the number is, but what we know, it is positive. So this part is going to be positive. Then how about f double prime at 0? This is 6 times 0 squared minus 6 over 0 squared plus 3 to the power 3. This is minus 6 over 3 to the power 3. This is 27. This is a negative number, so this part is going to be negative. And f double prime at 2, this is going to be 6 times 2 squared minus 6. 2 squared plus 3 to the power 3. This gives me, well, again, this is 24 minus 6, it is 18. In the denominator, we have 7 to the power. This is again a positive number, so we get the positive number. So that's the sign table. And then step 3, use the test. Oops, sorry. Use the test. Meaning that add another row to the table, f, wherever f double prime is positive, the f is going to be concave upward. Wherever the f double prime is negative, the f is going to be concave downward, and here is. So then we found all the intervals. F is concave upward on the interval -infinity to -1, see up here, and from 1 to +infinity here. And it is concave downward on the interval from -1 to 1. Well, very quick summary, we have to find f double prime, we did in the first step, then find the sign table, we did in the second step, and when we have the sign table, we can use the test. Wherever the f double prime is positive, we have concave up. Wherever f double prime is negative, we have the function concave down.